Welcome everyone. In this video, I will talk about partial derivative and total derivative. In case if you are new to the channel, you should subscribe it and watch the video till the very end. Then only you will be able to understand the concepts in detail. In my videos, what I do, I start with very simple problem, and as we proceed, we increase the level of difficulty of the problem. So that helps a student to understand the concept better. So let's talk about partial derivative. But before I talk about partial derivative, we just want to recall that let us talk about a function in one variable, that is y is equal to f of x, where x is known as independent variable and y is known as dependent variable. So if I ask you what is dy by dx, so you might be aware that dy by dx can be defined as limit h tends to 0 f of x comma x x plus h, f of x plus h minus f of x divided by h. So this is how we define the derivative of y with respect to x in case y is a function of x, right? And all the results in differentiation that we use are basically obtained using this definition only, and sometimes this is also known as the differentiation by first principle. So you might be aware about this. Here in case of partial derivative, we extend the idea, but the important observation is that when we are talking about partial derivative, then inherently it is going to be based on a function having more than one independent variable. So if you look at this function, the function has two independent variable, that is x and y, and the dependent variable here is z. And if I am differentiating this function partially with respect to x, how do I define the partial derivative? So we write limit h tends to 0 and f of x plus h comma y minus f of x comma y divided by h. So did you notice one thing, that when I am differentiating partially with respect to x, I am not changing the variable y. I am keeping the variable y as constant, and I am making a change in the variable x only. So by partial derivative, what we mean that if I am differentiating the function with respect to one particular variable, which is x in this case, I am going to keep all other variables as the constant, and this is the fundamental rule. Suppose I am differentiating the function with respect to y. So in that case, what we do, we take limit k tends to 0 f of x comma y plus k minus f of x comma y divided by k. So did you notice this point or not, that here since I am differentiating it partially with respect to y, I am keeping the variable x as constant and I am changing only the variable y. So when I am differentiating it partially with respect to y, I am keeping all other variable as constant. Here we have two variables, so I am keeping the variable x as constant. So I have taken a very small problem, and using the definition I want to solve this problem. Okay, so ideally if you ask me that what is the partial derivative of the function with respect to x, so using the idea that when I am differentiating the function with respect to x, I have to keep all other variables as constant. So y square should be treated as constant and 1 should also be considered as a constant. So if I differentiate it, I will just get 2x, and if I differentiate the function partially with respect to y, then I will keep x square as constant and 1 already is a constant, so the derivative of y square will be 2y. But using the definition, I just want to show you, and actually this is just for your understanding. For problem solving, we follow the rules of derivatives, we do not use the definition. But just in case if you want to understand this, that how this definition works, I am going to differentiate partially this function with respect to x. So what will be del f by del x? As per the definition, it is the limit h tends to 0 f of x plus h comma y minus f of x comma y divided by h. So if the function is this, so what is f of x plus h comma y? So I will write limit h tends to 0, and in place of x I am going to write x plus h square. In place of y y square I am going to put y square because we have y, and then plus 1, and minus, this is the value of f of x plus h comma y, so this, and minus I have this f of xy, so I will write x square plus y square plus 1, and that I divide by h. So did you notice that this y square and minus this y square will cancel, this 1 and here this will be minus 1, that will be cancelled, and from the first term I will get what? I will get limit h tends to 0, x plus h whole square, that is nothing but x square plus 2x into h plus h square minus x square divided by h. So this x square and x square is cancelled. Now to evaluate the limit I am going to take h common, so I took h common, and here I am writing 2x plus h, and this is divided by h, so this h and h cancel, and if I put h tends to 0, this limit will give me the value 2x, which I already have got here. So you can clearly see that the definition is based on the same idea which we have used in ordinary differential. We are using the same idea in partial differential also. Now before I take this problem, I want to highlight the point that all the rules of differentiation works here in case of partial derivatives as well. Only change is that when I am differentiating something partially with respect to one particular variable, suppose x, then I have to keep all other variables as constant. This is the main rule. There is no other difference in between the differential and the partial differential. Okay. Now let us solve different kind of problem. So first is evaluate the first order partial derivatives of this function at the point 1 comma minus 1. So in the statement it is written that you have to differentiate, or you have to evaluate the first order partial derivatives. It means what? That function is of two variable x and y, so we have to differentiate it with respect to x as well as with respect to y, because they have not specified, they have used the term first order partial derivatives, means we have to find both derivative with respect to x as well as derivative with respect to y. So let us first find derivative with respect to x. So del by del x of, what is the function here? The function here is x to the power 4 minus x square y square plus y to the power 4. So if I differentiate it, x to the power 4 using the rules of derivative, I will get 4x cube, x square y square. Since I am differentiating it with respect to x, I have to treat y and in turn y square as constant. So I can write minus y square as constant, and derivative of x square will give me 2x, and plus derivative of y to the power 4 being a constant will be 0. So I just got 4x cube minus 2x y square. But we have to evaluate the partial derivative at the given point. The point that is given is 1 comma minus 1, and this is how you usually write it, that partial derivative at the point 1 comma minus 1. So the function value like x value is 1, so 4 into 1 cube minus 2 into 1 into minus 1 square. So that is equal to 4 and minus 2, which is equal to 2. Now if I find this partial derivative with respect to y, I will do what? I will write del by del y of x to the power 4 minus x square y square plus y to the power 4. Since I am differentiating it with respect to y, I have to treat x as constant, so the derivative of x to the power 4 will be 0, minus, here I have to keep x square as constant, so I will write minus x square. Derivative of y square is 2y, and derivative of y to the power 4 is 4y cube. Now if I have to evaluate the function this derivative value at 1 comma minus 1, I have to substitute that point. So minus, here we have 2, x square value is 1 square, and then y value is minus 1, and plus 4 into this y value is minus 1, so that is minus 1 cube. So what did I get? This minus and this minus will become plus, and this will be minus, so the value is minus 2. So this was a very simple problem, and we have evaluated the partial derivative with respect to x as well as with respect to y at the given point. Moving ahead, let us evaluate the partial derivative of the function and both with respect to x and with respect to y at the given point 3 comma 4. So here if you look at the function using the property of log, because if I directly differentiate it will be quite complicated. So first I rewrite the function, and I rewrite the function using the property of log. So I write x square plus y square minus x minus log of under root x square plus y square plus x. So we have to find the partial derivative of the function with respect to x, del z by del x. So what I will get? The derivative of this log. So you know the derivative of log is given by 1 by this thing. So it will be 1 by under root x square plus y square minus x. And then I have to differentiate this thing again with respect to x, because we are using the chain rule of differentiation. So if I differentiate this with respect to x, what will I get? Derivative of under root x is 1 by 2 under root, and here it will be 2 under root x square plus y square, and derivative of x square is 2x. And if I differentiate this minus x term, I will get minus 1. And here if I go to the next term, I will get 1 by under root x square plus y square plus x. And then again the same thing, if I differentiate x square plus y square, I will get 2 times under root x square plus y square, and into derivative with respect to x is 2x, and this will give me plus 1. So you can simplify this. So to simplify, I cancel this 2 and 2 here, I cancel this 2 and 2 here. And since I have to evaluate the value at 3 comma 4, so in spite of simplify, or let me write one more step, otherwise it may be confusing for you. So I write it under root x square plus y square minus x, and if you simplify this, it will be x minus under root x square plus y square divided by under root x square plus y square, and minus 1 by under root x square plus y square plus x. And here it is x plus, this is x, so x plus under root x square plus y square by under root x square plus y square. So the best part is that this term here and this term here will be cancelled, and you can take minus common from this. So if you just cancel this term and this term, you will get a minus 1. So I just cancel this term and this term also, but I get a minus 1, because if I take minus common, this term will become the same. So I will get minus 1 by under root x square plus y square, and from this also I get minus 1 by under root x square plus y square. So I will get what? I will get minus 2 by under root x square plus y square. And since we have to evaluate the value at point 3 comma 4, so at point 3 comma 4, what will be the value of del z by del x? The value of del z by del x will be minus 2 and under root 3 square plus 4 square. So it is 25, so it will be minus 2 by 5. So I have got the derivative of the function z with respect to x at point 3 comma 4 is minus 2 by 5. Now my question is, and I would request you that in case if you are watching the video, I would suggest you that find del z by del y, right, and give me the answer in the comment section, and let me see that how many of you are able to give the answer correctly, because the idea is same. Only thing is that you have to differentiate it with respect to y now. Now let us take some very few quick problems like these are MCQ type question. It will not take more than 20-30 seconds to answer. So here also we have to evaluate the first order partial derivative at the point 2, 3. So the function f of x, y, and again using the property of log I can write it ln x minus ln y. And if I ask you what is del f by del x, it will be 1 by x. And if I ask you what is del f by del y, it will be minus 1 by y. So at the point 2, 3, the function value I have to put x value 2, so this will be 1 by 2 and this will be equal to minus 1 by 3. So the del f by del x is 1 by 2, del f by del y is minus 1 by 3. So this can be asked as a MCQ question, that what is del f by del x or del f by del y. So respectively it will be this. Similarly, if I talk about this problem, that we have the function f of x, y given by x square e to the power y by x, and if I have to find del f by del x, how will I find? I will take x square, the first function, and then we have to differentiate the second function, that is del by del x e to the power y by x, and then we have the second function, that is e to the power y by x and del by del x of x square. As I already have highlighted that all the rules of differentiation can be used here in case of partial derivative also. So here I am applying the product rule. So x square, and if I differentiate e to the power y by x, first of all I will get e to the power y by x. But I have to differentiate y by x again. Let me write it, this step, del by del x of y by x. It is not needed here, I am just writing for your understanding. And here I will get e to the power y by x, and del by del x of x square is equal to 2x. So finally if I write it, x square e to the power y by x, and del by del x of y by x is what? Y is a constant. So del by del x of 1 by x is minus 1 by x square, and plus 2x e to the power y by x. So let us do simplification. This x square and this x square is cancelled, and I get minus y e to the power y by x, and I get plus 2x e to the power y by x. So at the point 4, 2, what is del f by del x? So the value of y we take is minus 2, and e to the power y by x. So basically what is y by x? Y by x is 2 by 4, so that is 1 by 2. So e to the power 1 by 2 is nothing but under root e, and plus 2 into x. So what is the x value? X value is 4. So 2 into 4 is 8, and under root e. So what I get is 6 under root e. So the value of del f by del x is 6 under root e. And if I have to evaluate del f by del y, so what I will get? I will write del by del y of x square e to the power y by x. So this time we don't have to use the product rule because x square is already a constant, so it can be taken out, and I have to differentiate e to the power y by x. So whose derivative will be e to the power y by x into derivative of y by x with respect to y. So 1 by x will be a constant and derivative of y will be 1. So I get this. So this x and x cancel. So what I get is x into e to the power y by x. They are expecting us to evaluate at the point 4, 2. So at 4, 2, del f by del y will be x is 4 and e to the power 1 by 2. So that is under root e. So the value of this is 4 under root e. Now let us evaluate this problem. So here they are asking evaluate the first order partial derivative of this function, which is a function of 3 variables now, x, y and z, and they have specified the point like 3, 5 and 3, 5, pi by 2. So without any delay, let's start it. First of all, I have to find del f by del x. So it means I have to write del by del x of xy to the power sine z. Now important thing to note here, that if I am differentiating it with respect to x, Z is a constant, and since Z is a constant, sine Z will also be a constant. So we can apply the formula sine Z and xy to the power sine Z minus 1. Okay, but I also have to differentiate xy, because first I have differentiated it with respect to sine Z, right? Sorry, we have differentiated it with respect to xy, and then I have to differentiate xy with respect to x. So if I differentiate xy with respect to x, this y is constant and del x by del x is equal to 1. So this is what I will get. I will suggest you to pause the video and think about it, that whether you got this point or not. And they have given us the point 3 comma 5 comma pi by 2. So at the given point, just to save the space, I am writing here. So at 3 comma 5 comma pi by 2, if I have to evaluate del f by del x here, sine z, so sine pi by 2, sine pi by 2 is 1, and into xy, so x is 3, y is 5, and sine z means sine pi by 2, that will be 1, so 1 minus 1, and y value is 5. So what did I get? I got 3 into 5, 15 to the power 0, so that will also be 1, and into 5, so this value is equal to 5. Now quickly pause the video and tell me what will be del f by del y, and I will use the word symmetry. Can you answer it without solving the problem? If you can answer it without solving the problem, it will be better, and that can be done. So let me first answer it, and then I will explain the thing that what I was expecting from you. So if I have to evaluate del by del y of xy to the power sine z, what it will be? Again, using the same idea, sine z is a constant, and it can be written as xy to the power sine z minus 1, and again xy with respect to y. So this time x will be a constant, and derivative of y with respect to y will be 1. So if I take the point at 3 comma 5 comma pi by 2, the function value, that is del f by del y, will be what? Sine pi by 2 will be equal to 1, x into y, that is 3 into 5 to the power sine z. So sine z is 1 minus 1, and x value is equal to 3, so I will get 3. And I could have imagined that it will come to be 3, because you can see this function here, xy sine z. Basically, if I am differentiating it with respect to x and with respect to y, I will be like with respect to x I am getting here y, with respect to y I will be getting here x. All other terms will remain same, so that is why I could have guessed it. Anyway, we have followed the process also and calculated. But the next thing that we are going to calculate, that is del f by del z. So this will be like del by del z of xy to the power sine z. And this time the z is not a constant. So to use this, I am going to recall a formula that you have studied in your high school, that d by dx of a to the power x is a to the power x into log a. So here, if I have to differentiate this with respect to z, xy will be a constant, because I am differentiating it partially with respect to z. So it can be, xy can be seen as a constant, that is a, and then I will apply the formula. So a to the power x, so I will get what? I will get xy to the power sine z, right? In place of x we have sine z, in place of x a we have xy. But to differentiate it, first we have to differentiate this with respect to what? With respect to sine z, because if it is a to the power x, I am differentiating it with respect to x first. So if it is xy to the power sine z, I have to differentiate it with respect to sine z first, and then sine z with respect to z. So we have written a to the power x and log a, so it will be log xy, and then derivative of sine z with respect to z will be cos z, okay, using the chain rule. So at the point, which point? At the point 3 comma 5 comma pi by 2, what will be the function value? Del f by del z value, I will not evaluate all the terms. I will just look at the cos z, and we know that cos pi by 2 is equal to 0. So 0 multiplied into anything will become 0. So it is simply 0. So I hope you have got the problem, and in case if you have doubt, just rewatch it and try to solve it on your own. Let us solve this problem. So if z is equal to this, we have to prove this. So to solve this, what we have to do, first of all, we have to write z in terms of x and y. So that is x square plus y square by x plus y. And we want del z by del x, so let us calculate del z by del x. So that will give me what? That will give me del by del x of x square plus y square by x plus y. So using the u/v formula, I will write x plus y del by del x of x square plus y square minus x square plus y square del by del x of x plus y divided by this x plus y whole square. Okay, so I will get what? I will get x plus y del by del x of x square is 2x minus x square plus y square into 1 divided by this x plus y whole square. So here we get 2x square from this term and minus x square from this. So I will get x square. I will get 2xy. So I am writing 2xy. And from here I will get minus y square. So I wrote y square divided by x plus y whole square. Now why I have chosen this problem? Because I have calculated del z by del x. But I don't have to calculate del z by del y separately, because this is kind of symmetrical here. You see this function x square plus y square. So if I write y in place of x, so it will become y square, and x in place of y, it will become x square, and the same will be like y plus x. So it is a symmetrical function in terms of x and y. So using the symmetry argument, I can write del z by del y. When we are differentiating z with respect to x, I am getting minus y square. So with respect to y, I should get minus x square. So I will write y square here plus 2xy and minus x square and divided by x plus y whole square. Now I have to evaluate this term. So to evaluate this term, I will write del z by del x minus del z by del y. And so this will be what? This term minus this term. So you can see the denominators are common in both. So I can take the denominators common, x plus y square, and then this numerator minus this numerator. So x square plus 2xy minus y square, and then minus here I will have y square, and I will have plus 2xy, and I will have minus x square. So what can we cancel? We will cancel this 2xy and this 2xy, and x square from here, and minus plus x square from there. So I will get 2 times x square, and minus y square from here, and minus y square from here. So I will get minus y square divided by x plus y whole square. So basically, what is del z by del x? Del z by del x minus del z by del y is equal to 2x square minus y square can be written as 2 times x plus y into x minus y, and which we can divide by x plus y whole square. So this x plus y and this x square will cancel. So what I will get is 2 times x minus y divided by x plus y. Okay, so let us move to the next page because we don't have a space here. So what we have got is, we have got del z by del x minus del z by del y, and actually we have to square this term, because in the left hand side we have a square. So if I take the square of this, I will get 4 times x minus y whole square by x plus y whole square. So I write this is equal to 4 times x minus y by x plus y whole square. So this is what we have got here. In the right hand side we have to calculate 4 times 1 minus del z by del x minus del z by del y. So I think this is not a very difficult thing. If I write 1 minus and 4, let me first write it del z by del x minus del z by del y. So this is equal to 4 times 1 minus, and what is del z by del x? We can remember this, x square plus 2xy minus y square. So x square plus 2xy minus y square divided by x plus y whole square, and then minus del z by del y will be y square plus 2xy minus x square divided by x plus y whole square. This is just calculation, nothing else, but doing calculation should also be done very carefully. So now you can see that I can take x plus y square as the LCM, so I will write x plus y whole square minus this thing, so I will get minus x square minus 2xy and plus y square. I hope you got it. In case if you have doubt, you put this in bracket, right? And then I will have minus this, so I will get minus x square minus 2xy and plus y, minus y square minus 2xy and plus x square. So this is plus x square. Let me remove this, otherwise it will create confusion. And the whole thing here is divided by what? It is divided by x plus y whole square. So let us do simplification. This minus x square and plus x square cancel, this y square and this minus y square is cancel, and you see I will get x plus y whole square. So I will get what? I will get x square plus 2xy plus y square, and then we have minus 2xy, and we have also one extra minus 2xy. We could have simply written it x minus, if you remember the identities, but for your convenience I am writing the detail. So x plus y square. So this 2xy and minus 2xy is cancelled. So what did I get? Here we are getting x square minus 2xy plus y square. So that is basically x minus y whole square and x plus y whole square, which can also be written as the way I have written the first expression, x minus y by x plus y whole square. So what we proved? We proved left hand side is equal to right hand side. So this kind of problems we have done in our early childhood, proving left hand side is equal to right hand side, and that we did here also. Before I move to the total differential, let us quickly solve this problem. As I told you that in my videos you will find a lot of problem solving, because problem solving helps you to get the better concepts and have sufficient practice as well. So let us do this problem. So del z by del x, so this is the function, this function multiplied by f of ax minus by. So I don't basically know that what is the function f, but what I know that this function f is a function of ax minus by. So to solve this, first of all we have to find del z by del x. So how do I find del z by del x? That is del by del x of e to the power ax plus by into f of ax minus by. So I have to use the product rule. This has the first function and this has the second function. So e to the power ax plus by and derivative of this function. So I don't know what this function is. So if I have to differentiate, I am writing the derivative as just f dash. F dash is the derivative of the function f. So I am writing f dash ax minus by. Derivative of a function of ax minus by with respect to ax minus by is f dash of ax minus by. But since I am differentiating it partially with respect to x, I have to differentiate ax minus by also with respect to x, so that will give me a, right? And then plus I will take the second function, that is f of ax minus by, and I have to differentiate this, so I will get e to the power ax plus by into the derivative of this with respect to x, right, ax plus by. So this will give me a. So I have got this thing. Similarly, if I calculate del z by del y, what I will get? I am writing del by del y of e to the power ax plus by and f of ax minus by. So in this case, again using the same argument, I will get e to the power ax plus by first function. Derivative of the function f, since we don't know what it is, I will just write f dash ax minus by. But this time, since I am differentiating it with respect to y, I will get minus b, right? And plus, again I have to write the second function, that is f of ax minus by, and the derivative of first function, that is e to the power ax plus by into derivative of ax plus by, that is b. Now in the left hand side we have b times del z by del x plus a times del z by del y. So to evaluate it, I have to multiply this whole thing by a. So sorry, b. So here we have a, and if I multiply it by b, I will get ab. And we have e to the power ax plus by into f dash ax minus by. And by b, again I will get plus ab e to the power ax plus by f of ax minus by. And then by a, so I will get minus ab e to the power ax plus by f dash ax minus by. And again by a, so I will get here plus ab f of ax minus by. I'm multiplying in this term, and e to the power ax plus by. I hope I have not made any mistake. So now can we cancel some of the term? We have minus ab e to the power ax plus by f dash ax minus by, and plus ab. So this term here and this term, no, this is f dash, not this term. F dash term here and f dash term here. So these two terms actually will cancel. Let me remove this here. Just give me a moment. So these two terms here is cancelled. So what I am getting? I am getting this term. So AB and AB, 2AB, right? And other terms are same. You can see e to the power x plus by, e to the power x plus by, and f of x minus by. So I write e to the power ax plus by and f of ax minus by. So did you realize that what I got? I got this time like here, this whole thing is z, so 2ab, and this whole thing is z, so I got 2abz, and that is why we can write here that we have proved the result. So now we have done a lot of practice related to the partial derivative. Now let us talk about total differential. So how is total differential defined? So let we have a function of two variable f of xy, which is defined in some domain D in the xy plane. Then the total differential of z is given by dz is equal to del z by del x into dx plus del z by del y into dy. So basically, what is the total differential? When we are differentiating the function partially, we are keeping the other variable as constant. But by total differential, what we basically mean that the function is changing in both x and y direction, and if we want to measure the change in z, then we can use the total differential. So total differential is actually used to find the approximation for the change in z for a small change in x and a small change in y. So the dx is a change in x, dx gives you the change in x, and dy gives you the change in y, then dz gives you the change in terms of z, right? So this is how it is defined, and this is how it can be calculated. So if I have to explain it through some problem, let us take this problem. That, and this idea basically can be generalized for any number of variable. So suppose we have a function which is of n variables, x1, x2 up to xn. Then if I ask you what is the total differential of z, so it will be partial derivative of f with respect to x1 times dx1 plus partial derivative of f with respect to x2 times dx2, and so on up to the partial derivative of f with respect to xn times dxn. So this is how the total differential of z is defined. So let us solve a few problems quickly to understand it better. And the concept of total differential is used quite frequently, especially in differential equation, and we are also going to use it in case of integrals, where we will be changing the function into the form of total differential to see that whether this is dependent on path or not dependent on path. So it will be used quite frequently, and it can also be used to find the value of z, the rate of change of z in case the change in x and y is given. So it can be used for evaluation for change in z as well. So let us evaluate it. So what is the total differential of dz? And when I am writing the total differential, I am just writing dz, because since I am not differentiating it with respect to x or with respect to y, so I am just writing dz, which gives us the idea that both x and y are changing, right? So how it is defined? It is defined as del z by del x dx plus del z by del y dy. So it means that I have to differentiate this function with respect to x. So the derivative of this will be 1 by 1 plus x square plus y square, and then again we have to differentiate x by y with respect to x. So I will get 1 by y, and we have dx, and plus with respect to y I will get 1 by 1 plus x square by y square, and derivative will be like x by y with respect to y will give me minus x by y square, because x will be a constant and derivative of 1 by y means, if you remember, d by dy of 1 by y, it is nothing but minus 1 by y square. So the derivative of y with respect to 1 by y with respect to y will be minus 1 by y square, and then it is dy. So it can be simplified. I can write y square by x square plus y square into 1 by y dx plus y square by x square plus y square minus x by y square dy. So this y and this y is cancelled. This y square here and this y square here is cancelled. So what will I get from this? I will get y dx, and from this, the second term, I will get minus x dy, and the whole thing by x square plus y square. So this is the total differential of the function z is equal to tan inverse x by y. Let us quickly solve this problem, which involves three variables x, y and z, and it is defined as u is equal to this. So if I have to find the total differential of u, I will write it du, and it will be defined as del u by del x dx plus del u by del y dy plus del u by del z dz, right? So where dx, dy and dz are changes in x, y and z respectively, and this expression will give you the change in terms of u. So what is del u by del x? So if you have to differentiate this with respect to x partially, the y should be treated as constant. So it will be y times xz plus x by z to the power y minus 1. And then we have to differentiate it with respect to what? We have to differentiate it with respect to x. So in the bracket, derivative of xz, I will get z, and derivative of x by z, so I will get what? I will get plus 1 by z, right? And this is dx. Now with respect to y, again here y, with respect to y, we have to use this formula which I discussed in one of the problem earlier, that d by dx of a to the power x is equal to a to the power x log a. So here with respect to y, I will get a to the power y, means this thing, xz plus x by z to the power y, then log a means log of xz plus x by z, and since I am differentiating it with respect to y, right, and here this is no term of y, so this is what it will be, and here I will write dy, and plus del u by del z, again y will be treated as a constant, so I will write y xz plus x by z to the power y minus 1, and this time in the bracket we have this, so I have to differentiate it with respect to z. So x will be a constant, so I will write x, and again x will be a constant, but derivative of 1 by z is minus 1 by z square, so I will get minus x by z square, and then we have the term dz. So this is how the differential of u, the total differential of u will look like. Here we have extended the idea, like in case here I have taken just 2 terms, here I have taken 3 terms. In case if we have n terms, I will take n terms, right? So in this video I talked about a lot of problems related to partial differential and total differential. So that's all in this video. The next video will be related to derivatives of composite and implicit functions. We will be using chain rule of differentiation, and we will also talk about partial derivatives. So there will be a few more videos related to this topic or this unit that I will be uploading. So keep watching, share with your friends, and like the video as well. Thanks for watching. Have a great day.